We're going to take a look at an idea that comes up whenever we're working with radicals, and that's the idea of rationalizing, and more specifically, rationalizing the denominators of fractions. So rationalizing denominators. All right, so if I have a fraction like this, 1 over the square root of 2, for example, what I have currently is in my numerator, I have a whole number, it's 1, and then in my denominator I have another number, which we write as the square root of 2, but which is really this irrational number. If we wrote it's going to be like 1.41 something, something, something. It's going to go on forever, it's going to go on infinitely. It's never going to stop. So it is an irrational number. And so we have this idea in mathematics called rationalizing. It's whenever we have radicals in locations that we don't want to have them in. In this case, I do not want to have an irrational number in my denominator of my fraction. And so the question you might be asking yourself is why? Why do I not want a radical in my denominator? And the answer, truthfully, is, because we said so. It's just one of these ideas that mathematicians have come up with as far as we kind of want the standard way of reporting our numbers. In the same way that, we think that 2 over 4 is not simplified. This we should write in a simplified form as 1/2. They're equivalent, they're the same thing. But if I want to write 1 over root 2 as a rationalized fraction, I really want my radicals to be in the numerator of my fraction. So that's really the only reason. It's our standard way of reporting things, and so that's what we're going to take a look at here. So let's take a look at this 1 over root 2. And so I'm going to ask myself, how can I change an irrational number, square root of 2, into a rational number? And the answer, in this case, whenever I'm working with radicals, specifically square roots, is that I can just multiply it by itself. We know that if I take the square root of 2 and multiply it by the square root of 2, that is equal to the square root of 4, which is just 2. So any radical, any square root of a, if I multiply it by itself, it's essentially the same thing as squaring it, and so I will just get that number again. So when I have this situation, like 1 over the square root of 2, and I want to rationalize my denominator, so change this so that I no longer have a radical in the denominator of my fraction, what I can do is I can multiply it by the square root of 2. But if I don't want to change the fraction, whatever I do to the denominator, I have to do to the numerator as well. So what I'm actually going to do is I'm going to take this entire fraction and multiply it by the square root of 2 over the square root of 2. Since I'm multiplying by 1, it doesn't actually change the value. And so what I get is the square root of 2 over, well, what is the square root of 2 times the square root of 2? We already said that it is 2. So this is my rationalized form of this fraction that I started with. These are completely equivalent, but we prefer for it to be in this form in general. Because a lot of times it'll even give me like a better, more simplified answer. For example, if we have something like, numbers like 3 over the square root of 3, this can be better written as, well, so if I rationalize this, root 3, what I get is 3 root 3 over, what is root 3 times root 3? It's just 3. So this is equivalent to the square root of 3, which makes sense because whenever I'm dividing a number by another one, I'm just asking myself, what do I have to multiply to get this numerator here? So like, what do I have to multiply root 3 by to get to 3? It is root 3 again itself. So let's take a look at one more example, something that there's a little bit more involved. What if I have 4 over the square root of 27? So I go about this in a couple different ways. Let's just go about it in the simple way, which is I'm just going to multiply by the square root of 27 in both the numerator and the denominator, and what I'll be left with is 4 root 27 over 27. And so what you should be thinking, though, is the fact that, well, root 27, that's not fully simplified. I know that root 27, there's a perfect square that goes into there. So this is actually equal to 4 times, so this is a square root of 9 times the square root of 3 over 27. So root 9 is just 3, so this is 12 root 3 over 27. But then I can simplify this a little bit more because 3 comes out of both 12 and 27. And so what I get is 4 root 3 over 9. Now, I could have done that. I could have seen that from the beginning if I did this in a slightly different way. So I can either do my simplifying of my radical at the beginning or at the end. So in this case, I'm going to look at it a little bit differently. I'm going to do my simplifying the radical at the beginning. So I know that root 27, we just said, was equivalent to 3 root 3. So what this is equivalent to is 4 over 3 root 3. And so now I'm going to ask myself, well, what do I have to multiply the denominator by to get my radical out? And it's the same thing as before. I'm just multiplying by root 3 again. And when I do that, so multiply by root 3 over root 3, and what I get is 4 root 3 over root 3 times root 3 is 3 times 3 is 9. And so these are, of course, equivalent to each other. Two different ways about going about the same thing. It's just kind of whatever you want to do first, because both of them are simplifying techniques, right? None of this has changed the number. Both of these are equivalent to what I started off with, which is this 4 over root 27. But again, our rationalizing the denominator is just a way of simplifying my fractions into a format that we've kind of standardized. So that's all there really is to it when I am rationalizing denominators. My goal is just to get the radical or the irrational number outside of the denominator, and I do that by generally multiplying by itself while multiplying the fraction by 1 to get that result. So that's it.